Question number 1. Find the volume of a box if its length, breadth and height are 20 cm, 10.5 cm and 8 cm respectively. Means here length L, this length L is equal to 20 cm, breadth B, that is 10.5 centimeter, and height H is equal to 8 centimeters. Have you got this? Now, with the help of this given information, we will find or calculate volume of the cuboid. We will find or calculate the volume of the cuboid. Here cuboidal box is given, so we will find or calculate the volume of cuboidal box. Have you got this? Now for this we know the formula for volume of cuboidal box, means cuboid. Now look here, this is our cuboidal box. In this cuboidal box, this is the length here at the bottom, length, and this is the breadth, and at thumb there is a length. Okay, and here this is the height of this cuboidal box. Have you got this? Now here we will find the volume of this cuboidal box by using formula. Volume of a cuboidal box is equal to L into B into H. Now we substitute values of L here, values of L, B and H. Therefore we get here volume of cuboidal box is equal to value of L 20, then value of B 10.5 and value of H height, that is 8, means 20 into 10.5 into 8. Now we multiply all these three terms. Now here volume of a cuboidal box. Now see this, 20 into 8, 20 into 8, 160, that is 160 into 10.5. The multiplication of 160 into 10.5 is 1680 cubic centimeter, because all these are, means these three terms are in centimeter. So centimeter into centimeter into centimeter means centimeter cube, or centimeter we write this way, centimeter cube, or we write cubic centimeter. Therefore the volume of the box is 1680 cubic centimeter. Here a cuboid shaped soap bar has volume 150 cubic centimeter. Find its thickness. Thickness means height. Here find its thickness. Thickness means height. If its length is 10 centimeter, length is given 10 centimeter, and breadth is given 5 centimeter. With the help of given information, we will find thickness, that is height of that soap bar. Now here first we write given. Given for cuboid shaped soap bar. First we write given information from this question. Now what is given? Length is given. length, that is small l, is equal to 10 centimeter. Breadth is given, that breadth is, look here carefully. Now breadth is given, breadth B is equal to 5 centimeter, and its volume is given, volume is equal to 150 cubic centimeter or centimeter cube. These are given values of length L is equal to 10 centimeter, breadth B is equal to 5 centimeter, and volume is equal to 150 cubic centimeter. From this, we want to find thickness, that is height of that soap bar, height of the soap bar. Height of the soap bar is equal to, we take small h. By using formula for volume, volume of a soap bar, volume of a soap bar is equal to L into B into H. I have shown here, this is the cuboidal shape box here, but we consider this is a soap bar. Then it has a length, then breadth at here bottom. This is length, then this is here breadth, and this is the height. Now with the help of this information, what is information now? L is equal to 10 centimeter, B is equal to 5 centimeter, and volume is equal to 150 cubic centimeter. With the help of this, we will find the thickness, or that is we say height of that soap bar. Therefore, volume of a soap bar is equal to L into B into H. Have you got this? Now we put here values. Volume of soap bar, that is 150 cubic centimeter. Then we put value of L, 10 centimeter. Then into value of B, 5. And we don't know value of H, so we write as it is. Means volume of a soap bar is equal to 150 is equal to 10 into 5 into H. Now we multiply here 10 into 5, 50. So we obtain here, series 10 into 5, 50. Therefore, 150 as it is equal to 10 into 5, 50, and H as it is. Now, next step, we take this 50 to the left side. We take this 50 to the left side. Now 50 here multiplied with H. When we take this 50 to the left side, then becomes divisor. I will write here this H to the left side and 150 upon 50 to the right side. Therefore, here 0, 0 cancelled, and 5 3s are 15. 5 3s are 15. Okay. Therefore, H is equal to 3. H is equal to 3. That is, H is equal to 3 centimeter. Means the thickness, that is the height of the soap bar is 3 centimeter. What is this question? How many bricks of length, bricks, those are very small as compared to wall. How many bricks of length 25 centimeter, breadth 15 centimeter, and height 10 centimeter are required to build a wall of a length, length of a wall is given 6 meter, because wall made from bricks. So wall is bigger, so its length is 6 meter, height is 2.5 meter, and breadth is 0.5 meter. Now first we write given information here. Look here carefully. Now what is given? First, for the cuboidal shape brick, that is small in size. Now for this cuboidal shape brick, we first write length in bracket small l. For brick, we write small l is equal to 25 centimeter. Then breadth b is equal to 15 centimeter, and height of the brick that is 10 centimeter. Okay. Now here for the cuboidal wall, length capital L is equal to 6 meter. Now the dimensions of brick are in centimeter, so we convert this meter into centimeter. Capital L is equal to 6 meter. We convert it into centimeter. For that, 1 meter is equal to 100 centimeter. So we write here 6 meter we convert into centimeter. Therefore we write here 6 into 100 means L is equal to 6 meter is equal to 6 into 100 centimeter is equal to 600 centimeter. Have you got this? Same way, height of the wall, capital H, is equal to 2.5 meter. Now we also convert here meter into centimeter. Therefore, 2.5 meter is equal to 2.5 into 100 centimeter is equal to 250 centimeter. Same way, we convert this breadth B, capital B is equal to 0.5 meter. Meter we convert into centimeter. Therefore, here 0.5 meter is equal to 0.5 into 100 centimeter is equal to 50 centimeter. This way, first we convert meter into centimeter. Then we use direct formula for this, that is number of bricks, means total bricks required to make that a particular wall. So number of bricks is equal to volume of wall, bigger one first, numerator, volume of this wall, that is bigger one, no? So we write volume of wall at the numerator upon volume of brick, that is smaller in size. So we write denominator. Now we write here, therefore number of bricks is equal to volume of wall, capital L into capital B into capital H, upon volume of brick, small l into small b into small h. Have you got this? Now here we put values of capital L, capital B, capital H. Those are, look here, number of bricks is equal to 600 into 250 into 50 upon 25 into 15 into 10. This way we put values. Now we here divide. Now look here. Now this 0 cancelled. Okay. Now here 5 3s are here 3. 5 1s are 5 and 5 3s are 15. Now we cancel this 25. 25 1s are 25 and 25 10s are 250. Okay. Now 3 1s are 3 and 3 2s are 6 and these two zeros. Have you got this? Now here number of bricks is equal to 200 into 10. 200 into 10. Therefore, number of bricks 200 into 10, the number of bricks is equal to 2000. This is our final answer. Therefore, 2000 bricks are required to build the wall.